All right, what up, everybody? Today we're talking about voltage, current, resistance, and power in a series circuit. So, first of all, what is a series circuit? A series circuit is a electrical circuit where there's just one loop. So every electrical charge that leaves the battery will have to go around the loop. There's no point at which it could go left or right. It's all only one way. Okay, the first thing we're going to talk about is voltage. So you probably see like there's voltage on batteries. The voltage of a circuit comes from the battery that you put in it. And so if this is a 12-volt battery, then there's 12 volts in the circuit. And voltage basically measures how hard a battery pushes on the electrical charges. Right? So the harder it pushes on it, the more potential energy it gives to the electrical charges in the circuit. The unit for voltage is volts, and it's a capital V when you write it after a number. Okay, the second big quantity that we need to talk about is resistance. Resistance is a measure of how much a component, such as a light bulb, slows down the flow of electricity. So electrical charges are moving here in the wire. It's very easy for them to move because the wire has an extremely low resistance. But once they get to the light bulb fights back on the electrical charges can't move as smoothly. It's kind of like the difference between driving on a freeway at 2 in the morning and then driving on a crowded, bumpy road. So the bigger this number, the harder it is for the electricity to travel. And so that's resistance is measured in ohms, and the symbol for ohms is this little. It's the Greek letter omega, and it kind of looks like this upside down horseshoe. So if you see that, you know it's talking about ohms resistance. All right, current. Current is a measure of how much electrical charges go through a given place. Um, and so if you can imagine that you're just choose one spot on the wire and you just count how many electrical charges go by in 1 second, then that would tell you how much current there is, right? The unit for current is amps, and an amp is quite a bit of electrons moving. It's about 6 quintillion electrons moving by every second. Now, contrary to popular belief, the electrons do not just like go around in a circle really fast. They actually move fairly slowly. The current is measured by not how fast the electrons themselves are moving, but how many of them are moving by. And so if you have a lot of them moving by, even though they're moving slowly, you have a large current. There is a relationship between voltage, current, and resistance, right? Voltage is equal to current times resistance. So you see the 2 times 6 will give you 12. Right? Power. Power is how fast energy is changed from one form to another. The unit for power is watts. And so in this circuit, there would be 24 watts because you find power by multiplying the voltage times current. So there's a 12-volt battery. The current coming out of it is 2 amps. So 12 times 2 is 24. So what that means is that 24 joules of energy are transferred from electric potential energy into light and heat energy by this light bulb every second. Okay, and it also means that the battery is doing 24 joules of work every second. So the battery keeps on doing work to add potential energy to the circuit, and the light bulb turns that potential energy into light and heat energy. All right, so here we introduce a VIRP chart, right? And this maybe isn't that useful for a circuit with one light bulb, but it will become very useful for circuits with more than that. Right, so a VIRP chart is a table that has one row for each light bulb and then a total row at the bottom. And it has columns for voltage, current, resistance, and power. And the reason it's called a VIRP chart is because V is for volts, I is a symbol for current, even though current doesn't start with I. R is for resistance, and P is for power. Okay, so on the VIRP charts, if you have a row where you know the current and the resistance, you can always multiply those two to get the voltage, right? So 2 times 6 is 12. Also, if you know the voltage and current, you can multiply those two to give you power, okay? But you have to stay in the same row. So the voltage in this row times the current in this row would equal the power in that row. right? So that tells us that there's 24 watts of power in the circuit. Let's look at a more complicated example. In this circuit, there are 3 light bulbs. We'll call them R1, R2, and R3. So just putting down the numbers that we see here, we know the resistance for R1 is 20. We know the resistance for R2 is 10. And we know that the voltage of the battery is 40 volts. And so we'll write that down. And we also see here that the current coming out of the second light bulb is 1. So we'll put a 1 right there. Now, as far as when you go up and down, there's some rules that apply to series circuits, right? And we're working with series circuits in this unit, so we can go by these rules. They're going to change when we do parallel circuits. But one rule is that the voltages of the light bulbs will add up to give you the voltage of the battery. So whatever these numbers are, the voltage for the 3 light bulbs, we'll add together those numbers and we'll get 40. Okay. The current is going to be the same everywhere. So we know that the current is 1 amp right here. That means it's going to be 1 amp everywhere, okay, whether it's near the battery or near the other light bulbs. So we'll actually be able to put ones here. And the resistance, just like the voltage, you add them together, and that gives you the total resistance. And the power you can add together to get the total power. So the first thing we're going to do is put 1 everywhere because the current everywhere is the same. Now, after doing that, we notice that we have 2 rows where we have both current and resistance. And where you have both current and resistance, you can multiply them to give you the voltage. So now we have the voltages, 20 volts for the first light bulb, 10 for the second. And then we have the third light bulb, and we don't know what the voltage is on that one. But what we do know is if you multiply these 3 numbers, you should get 40. So 20 times 20 plus 10 is 30. What plus 30 is going to give you 40? And the answer is 10. Okay, so the third light bulb here must have 10 volts across it. We can now find the resistance because resistance times current equals voltage. So something times 1 equals 10, and that would be 10. Right? Likewise, something times 1 equals 40, so that'd be 40. So the resistance of the third light bulb is 10, and the resistance of the whole circuit is 40. So that means that between when electricity leaves one side of the battery to when the current comes to the other side, it encounters 40 ohms of resistance. All right, finally, multiply the voltage times current, and that gives you the power. So we did that for all of the rows. And now we filled out the VIRP chart. One more example, right? And this time we get all 3 resistors and we get the battery, but we don't get anything with the current. So what are we going to do? We do know that if we add these resistances together, you get 8. Okay, so you're basically just looking for what you can know based on what you already know. And every time you make another step will open up. And in this case, we know that resistance times current gives you voltage, right? So we can figure out 8 times something equals 24, right? And that would be 3. The current everywhere should be the same, so we can fill in this whole column now. And from here on out, it gets easy because voltage equals current times resistance. And we have current and resistance for all of them, so we just multiply those numbers. To find power, we multiply voltage times current, right? And for all 4 of these rows, we have the voltage times current. We just have to multiply them. To check your work at the end, you can see does the power of all 3 light bulbs add up to give you the total power. And 9 plus 27 is 36, plus 36 again is 72. So actually that works out. So that's a good sign that we did that correctly. All right, so that's how you do VIRP charts for series circuits. We'll change the rules for parallel circuits, and I'll make another video for that.